a vector sign over P. Okay. Now we will study something more about dipole. We need to find electric field at an axial point of a dipole. As we can see over here, there is a dipole from the left hand side, minus q plus q, distance between them is 2a. This is a point P. We need to find the electric field at the point P due to this dipole. The distance of point P from the center of the dipole is r. Then what will be the distance of the point P from the minus charge? It will be r plus a, and the plus charge it will be r minus a. Okay. And if you want to find the electric field at point P, you must place a charge plus 1 over there. The test charge is always taken as positive, and what we are placing over there? We are placing plus 1 charge at point P. Okay, and we know the formula of electric field is what? 1 by 4 pi epsilon naught q by distance square. So here the electric field due to negative charge is 1 by 4 pi epsilon naught q divided by distance between them. So from minus charge the distance is r plus a, so it will be r plus a whole square. For the plus charge the distance is r minus a, so you can see in the below over there that it is r minus a whole square. The direction of E minus q will be negative left side, and the direction of E plus q will be right hand side, because minus q and plus charges will attract each other, and plus q and plus 1 charges will repel each other. Therefore, if you want to find the resultant electric field, you need to add this thing, E plus q plus E minus q. What you will see, q was common in both, and 1 by 4 was 4 pi epsilon naught was also common in both. So we have taken it common. What is left over there? 1 by r minus a whole square plus 1 by r plus a whole square. And you are good at maths, I know. After taking all the LCM and everything, what you will get? Q by 4 pi epsilon naught 4ar divided by r square minus a square whole square. Okay, this is also formula, but we can go for some other formulas also. Now we have at the numerator, in the numerator we have what? Q 4ar. We are adjusting it as 2aq into 2r without changing the format, without changing the formula. You can see it is now also it is 2 into 2 4 aqr, but why I have written 2aq over here? Remember last topic was what? Dipole moment, and p was what? P was 2aq. So that 2aq will be now replaced by p only. So the formula will be what? 2pr by 4 pi epsilon naught r square minus a square whole square. Okay. Now there is a special case over here. If r is much greater than a, if r is very much greater than a, then we can neglect a square in comparison of r square. Okay, we are neglecting that term. If we will neglect that a square over here in the bottom part in respect of r square, then what will happen? R square whole square, it will be r to the power 4. In the numerator there is 1 r, in the denominator there is 4 r. So 1 r will be cancelled, and we will get 3 r in the denominator, 1 by 4 pi epsilon naught 2 p by r cube. This was the question that to find the electric field at an axial point due to an electric dipole. Now we will go for another topic for the same dipole. Earlier we found what? The electric field at the axial point. Now we will find the electric field at the equatorial point. As you can see in this diagram, the right hand side, this one, that there are two charges again, minus q and plus q, and we need to find the point at the point. We need to find the electric field intensity at the point P, which is at the equatorial line. Okay, and this is a equilateral triangle. So all the angle will be leave about the angles. Just we are taking the angles as theta. Okay, so two angles will be same because we are taking the point P at an equilibrium equatorial point. So distance was 2a, so we have divided the AR as a and RB is also a. Now we need to find the electric field at the point P. So what we will do? We will place a charge plus 1 over there. So because of charge on A, there will be attractive force force over there, and because of charge plus q, there will be a repulsive force on p. You can see there are two forces acting on that, one on the upper left direction and one in the lower left direction, that is Pm and Pa. Now what in class 11 there was a chapter vector. In vector there was a topic resolution of vector. We used to resolve a vector into two components, cos theta and sin theta. Cos theta along which the angle is made and sin theta on the other side. You can see over here Pm and Po. Look what we have drawn one more diagram over here. The upper one was E plus Q, the lower one was E minus Q. Both were having an angle theta between them, so this will be side become E plus Q cos theta, E minus Q cos theta, and the upper will become what? E plus Q sin theta is minus Q sin theta. Now when we will find E minus Q and E plus Q from the formula of electric field, it will be 1 by 4 pi epsilon naught into charge by distance square. So while the distance is over here is r square plus a square under root, because it is at equatorial point, so it will be a right angle triangle. This is a and the distance is what? R. So this will be what? Under root r square plus a square. Similarly on the other side also it will be r square plus a square under root. Okay. So now we are going, as you can see from E minus Q and E plus Q, that both are same, only the difference is of direction. One is acting along PO and the other one is acting along PM. So both are equal but opposite because the direction is different. So in this diagram, if E plus Q and E minus Q are equal and opposite and sin theta is also equal, then this will be cancelled because E plus Q sin theta and E minus Q sin theta are equal and they are acting along the opposite direction. So it will be cancelled, but that E plus Q cos theta and E minus Q cos theta are acting in the same direction, so they will be added. We will do integration over here now. So you can see over here it will be 2 EQ cos theta because they are acting in the same direction. 2 is 2 only. At the place of EQ we will write the value of EQ 1 by 4 pi epsilon naught Q by under root r square plus a square into cos theta. From this diagram only, if you want to find cos theta, what is cos? Base by hypotenuse. So it will be what? A by under root r square plus a square. We will place it over here. Then what we are getting? We are getting 2qa by 4 pi epsilon naught r square plus a square to the power 3 by 2. Okay. So again 2qa we can replace it by p, that is dipole moment. So it will be what? 1 by 4 pi epsilon naught p by under root a square r square plus a square to the power 3 by 2. Again the special case was there. If r is much greater than a, then what will happen? EQ will be equals to 1 by 4 pi epsilon naught q by r square plus a square to the power 3 by 2. Okay. And if r is much greater than a, then a square can be neglected in compared to r square, and it will become 1 by 4 pi epsilon naught p by r cube. Okay. Now again over here you can see that E axial is always 2 times E equatorial, because E axial was what? 1 by 4 pi epsilon naught 2 p by r cube. E equatorial is what? 1 by 4 pi epsilon naught p by r cube. So there was 2 was extra in it axial, so the E axial is double of E equatorial. That you need to keep in mind. Suppose in a numerical you have been given E axial and you want to find equatorial. So simply you are dividing it by 2 and you are getting equatorial. So we are having our next topic, torque. Torque all of you have studied in class 11 also, in class 9 also. Torque is that force which produces a rotating effect on a body. Two equal and opposite forces makes a torque. Okay. Uniform electric field is what? The field where electric field remains common or constant for each and every point. You can see AB over here. AB is a dipole. At B there is a charge plus Q, and at A there is a charge minus Q. The distance between them is 2a. So we need to find the torque on this dipole when they are placed in an electric field. So as you can see, as we know that formula of force is what? Charge into electric field. So at B the force will be what? Plus Q into E, because at B the charge is plus Q, and at A that force is what? Minus Q into E, because at A the charge is what? Minus Q. Okay. But to find the torque, what is the formula? Force, any force, either plus QE or minus QE, into the perpendicular distance between them. As you can see over here, the perpendicular distance is what? BC. Between A and B the perpendicular distance is what? BC. Now how we can find perpendicular distance? Can we go for a triangle ABC? Sin theta is equals to BC by AC. So BC will be equal to what? AB sin theta. That BC is only perpendicular distance, and AB equals to what? AB is the distance between the two dipole. It is how much? It is 2A. So BC will be equals to 2A sin theta. Now to find for torque, force into perpendicular distance, as we know, force is QE and perpendicular distance is 2A sin theta. So it will be 2A QE sin theta. Again 2AQ is a dipole moment, so we can replace it by P. It is PE sin theta, and sin theta we know that it is a cross product, so it will be P vector cross E vector. If theta is 0, so sin 0 will be 0, then tau will be 0, and if theta is 90, sin 90 is 1, then tau will be PE. This is all the things we have studied about